Hello? Hello? Yes. Huh. Oh, okay. Hello? 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 Okay. Well, today we're back with another stream. But today we're going to be doing paper 6 of maths. Yeah. Starting the stream a bit early, but it's not very, it's quite early. Okay, so we're gonna be doing some maths today. Paper 6. And my exam is on Monday. So yeah. Let's just start with the paper. For question 1. In a survey of 200 randomly chosen students from a certain college, 23% of the students said that they owned the car. Calculate an approximate 93% confidence interval for the proportion of students from the college who own a car. So confidence interval. Let's draw the graph in the confidence first. So in the middle we have 93. So that means separating on the left and the right, it would have to be 3. Sorry, not 3. We have a difference of 7. So one whole side. So let's say the right side, we would actually have 96.5%. So we need to get the MF19 first. So let's see, it's 96.5. What would that give us? Nothing here. Let's see here. 0.965. So 9.811 or 9.812. So we just put 9.811. Sorry, 1.811. So 1.811 will be our z value. And going back to this, in a survey of 200 randomly chosen students from college, 23% of students said that they owned the car. So we would put p of root pq over n. So that means we would have our p is 23. So 0.23 plus minus 1.811 root of 0.23 times 0.77 over 200, which is our n value. So from this one, we will get 0.23 plus 1.811 root of 0.23 times 0.77 over 200. So if it's plus, we would get 0.284, and if it's minus, we would get 0.176. So that's your confidence. Okay, moving on. The random variable W has a Poisson distribution. State the relationship between EW and variance W. Let me move the OBS to now this one. We would have relationship between EW and variance W. Okay, so Poisson distribution. So for Poisson, when we split it to the variance and the mean, the mean and the variance will be the same value. So the relationship would just be that EW is equals to var W. Moving on to B. The random variable x has a distribution NP. Jyoti wishes to use Poisson distribution as an approximate distribution for x. Use the formula for Ex and variance x to explain why it is necessary for P to be close to 0 for this to be a reasonable approximation. Okay, so as we stated just now, EW is equals to variance W. So, oh wait, it is necessary for P to be close to 0. Oh. So why does P have to be close to 0? Ex and var x. Okay, so Ex would actually just be NP, and var x will be equals to NPQ. So why does P have to be close to 0? So we'll just write P has to be close to 0 as if P is close to 1, what is the answer for this? It's only one part. If P is close to 1, variance x will then be equal to Ex. No, this is wrong. But you never leave a question blank. Just answer it. We'll just look at the mark scheme later on. Okay. C. Given that y has the distribution b 20,000 0.00007, use a Poisson distribution to calculate an estimate of py mod 2. Okay, so our mean will be equals to NP, which is equals to 20,000 times 0.00007. That's 4 zeros. And you will get 20,000 times 0.00007. 705. So therefore your Poisson, let's say y is more than 2, so we'll bring in 2 for this one as well. Px is less than or equals to 2. Sorry, 1 minus Px is less than or equals to 2. So you have 1 minus e naught e to the power of negative 7 over 5 and 5, and 2 you have 7.7 over 5 to the power of 2 and divided by 2 factorial. That will give you 1 minus negative 7 over 5, 1 plus 7 over 5 plus 7 over 5, have to square it, square over 2 factorial. So the answer will be 0.1665, so it will just 167. 3A. Okay. What do you mean the audience is robotic? Is it still robotic though? Because I changed it to my mic really. Is it still robotic? I don't know. Okay, 3A. The masses in kilograms of newborn babies in country A are represented by the random variable X with mean and variance. The masses of a random sample of 100 newborn babies in this country were found, and the results are summarized below. Calculate the unbiased estimates. Oh shit. Okay, unbiased estimates. So for this one, you would do mean is equals to EX over N. That's it. Which is 1625 over 500, which gives you 3.25. And then for the next one, the variance, you will need to do n over n minus 1 bracket EX squared over n minus EX over n squared. So for this one, you will get 500 over 499 and 5663.5 over 500 minus, for what we calculated just now, 3.25 squared. You would get 500 divided by 499, 5663.5 divided by 400, 3.25 squared. So your answer would be 0.766. You know, I was actually just thinking of like starting the stream later than now because I was actually just really tired. No, not tired, just lazy. You know, like early on when I started this stream, like the first stream I started, I had like the motivation to do all this stuff, and a few days later the motivation just starts to die down, you know. For B, carry out the test at the first 1% significance level. A researcher wishes to test whether the mean mass of newborn babies in the neighboring country B is different from that in country A. He chooses a random sample of 16 newborn babies in country B and finds that their sample mean mass is 2.95. Assume that your unbiased estimates in A are the correct values of mean and variance squared. Alright? Assume also that the variance of the masses of newborn babies in country B is the same as in country A. Okay. Carry out the test at the 1% significance level. Okay. Sample of 60 and finds that the sample mean mass is 2.95. Okay, 2.95 mean. Okay, so Px is do more than, let's say that because it's different, right? Just because it's different, we can either do more than or less than as long as it's different. So yeah, so let's just start with more than 2.95 minus, sorry, not 2.95, 3.25. So we have to see that if it's the mean mass of the newborn babies in country B, because what we calculated just now is country A, so country B would be different. So that's why we have to take it to be more than our 3.25. So 3.25 minus 2.95 over our variance would be 0.766, so square of 0.766 over 60, also in the square, because you're taking it with 60 babies. So your z value will be more than 3.25 minus 3.25 minus 2.95 over root of 0.766 over 60. We would get 2.655. And then from this, we will find 2.659960. 9961. So we'll have 1 minus 0.9961, which gives us 0.0039, which is less than 0.1. Sorry, 0.01. Therefore, reject H naught enough evidence to show that enough evidence to show that mean mass of nu norm and B is different from A. Okay, next one for A. Okay, I'm gonna go take a piss first. Sorry it took some time. My mom told me to give her a massage. Okay, for A, stay in context on one condition for X to be modeled by a Poisson distribution. So, number of books received at a charity shop. So one condition would be books received by charity shop per day has to be constant. Because the books received is the event, and the event has to be constant. The event has to be independent. Okay, 4b. Assume now that X can be modeled by a Poisson distribution. Find the probability that exactly 10 books are received in a 3-day period. Okay, exactly 10. So X is equals to 10 in a 3-day period. Yeah, okay. So for this one, we would do, since 1 day is 5.1, 3 day will be 3 times 5.1. 15.3. So therefore, it will be e to the power negative 15.3 and 15.3 to the power of 10 over 10 factorial. That gives you negative 15.3 times 15.3 to 15.3 to the power of 10 over 10 factorial. You get 0.044. I doubt that's correct. No, it's such a low probability. Sorry, exactly 10 books. Yeah, okay, since the mean is 15.3, so you would have more than 10 books on average. Okay. I'm really insecure of using like Z flip books because it's like really you just do, once you see like a crease form in the middle, it's just heartbreaking. But mine has no crease yet. It's just the bump you see on all Z flip phones. It's really scary. Okay, moving on. Use a suitable approximation distribution to find probability that more than 180 books are received in a 30-day period. Okay, 180 books. So for C, we would do find the mean first. So we would have 30 days. So 30 times 5.1 gives us. So our NP, our mean is already more than 5. So that's why we can't use the Poisson. Okay, 153, 180 books, probability that X is more than 180 minus 153 over root of 153. Sorry, it's approximating distribution. So since it's more than, we'll have to do 180.5. That gives us Z more than 180.5 minus 153 divided by root of 153. 2.223, which gives us 1 minus the phi of 2.223, which gives us 2.2 9.868 9.869. So that will be 1 minus 0.9869. That gives us 0.0131. There we go. Moving on. For D. Just mute this first. Okay, for D, the number of DVDs received at the same shop is modeled by independent distribution, Poisson distribution with mean 2.5 per day. Find the probability that the total number of books and DVDs that are received at the shop in one day is more than 3. So for this one, since it's two totally different things, we will have to plus the means together. So we have 2.5 plus, what is the mean? Okay, 5.1 plus 5.1, we get 7.6. That's our mean. It's more than 3. So probability that x is more than 3. So we would find the 1 minus px is less than or equals to 3. So for this one, 1 minus e negative 7.61 plus 7.6 plus 7.6 squared 2 factorial plus 7.6 cubed over 3 factorial. There we get 1 minus negative 7.6 times 1 plus 7.6 plus 7.6 squared over 2 factorial plus 7.6 cubed over 3 factorial. We get 1 minus 0.05537, and therefore we get 0.945. Okay, moving on, 5a. 5a. Two random variables x and y have the independent distributions n7 to 3, 7, 3 and n6, 2 respectively. A random value of each variable is taken. Find the probability that the two values differ by more than 2. Okay, differ by more than 2. Random value of each variable is taken. Since it's using n, we would have it's given before already, np, oh no, that's binomial, so normal would be, okay, so the probability that the two values differ by more than 2, so the mean is 7 and 6, so let's find the mean for p x plus y first, so at x minus y, because we want the two value to have a difference of by more than 2. So it can be either more than 2 or less than 2. Okay. Oh, this is hard. Okay, it's a difference by more than 2, so anyway it goes. so it's minus. So you get 7 minus 6, which is equals to 1. And for the other one, we'll have the 3 plus 2. Since it's already squared, we don't have to square it again, since it's variance. So the variance of x minus y is equals to 3 plus 2, which is 5. So that's a variance. So the probability would be x more than, the difference is more than 2. I think we have to do it 2 ways. Negative 2 as well. Do we have to do it with negative 2 as well, or do we just do it 2? Like the difference is, just the difference is 2, right? So it doesn't matter, they didn't specify which way you have to find the difference, like the difference of y, x from y or y from x. Okay, just 2. So px more than 2. So pz is more than 2 minus 1 over root of 5. We would get 2 minus 1 over. So we will get z is more than 0.447. Yeah, I don't feel right about this. I feel like we have to do both sides, since I feel like we have to do both sides, negative 2 and 2. Oh, no, we'll just do 2. Okay, 0.447 for 0.6700, 0.6725. So we have 1 minus 0.6725, which gives us 1 minus 0.6725, 0.3275, so 0.328. That's your answer. So for part B, oh sorry, that's number 2. A2. Comment on the assumption that the variables t and p are. Oh no, that's for B. Okay, let's calculate B first. 5B. Each candidate's overall score in the science test is calculated as follows. The mark for theory is denoted by T. The mark for practical is denoted by P. And the overall score is given by T plus 1.5P. The variables t and p are assumed to be independent with distributions n62, 158, and n42, 108. You should assume that no continuity corrections are needed when using these distributions. A pass is awarded to candidates whose overall score is at least 90. Find the proportion of candidates who pass. Okay, that's a mouthful. So it's just pt plus 1.5p is more than 90. Sorry, at least. So more than or equals to 90. So the fact that you don't have to use continuity correction, you should assume, you still have to use continuity correction for when you put them together. But when you use these distributions individually, you wouldn't have to use continuity correction. That's just what it means. Okay, so here we would do, so we'll have t plus 1.5p. So that mean for t plus 1.5p should be equals to the mean for t, which is 62, plus 1.5, 42, 1.5 and times 42, which gives you 62 plus 1.5, 22, giving you 125. And for the variance, I think that's the variance, because those are quite big numbers. Okay, so you would have 108 plus it's 1.5. So is it 1.5 times? No, sorry, just do 1.5. 1.5. 108. Sorry, the previous is 150, 158. The other one is 108. That should give you 158 plus 1.5, 108, 320. So for it to be at least 90, you want to include 90 as well. So you do continuity correction, so it's minus 0.5 since you want to include 90 as well, so it's more than 89.5. And then you minus this by 125 divided by root of 320. So your P of Z would be more than 89.5 minus 125 divided by root of 320. You'll get more than negative 1.986. So this would just be the phi of 1.986, which gives you, is it here? No, it's not. 1.9864 here. So 1.9, 0.761, 0.765, 0.9765. So that'll just give you 0.977. So that's the probability. Oh, find the proportion of candidates who pass. What does that mean? Oh, yes. It's just the probability from the proportion. Okay, number 2. Comment on the assumption that the variables t and p are independent. So t and p has to be independent because students' performance on theory does not influence performance on practical. Okay, next one. 6A. We have 7, and I think that's all correct. 6. When a child completes an online exercise called a Mathlit, they might be awarded a medal. The publishers claim that the probability that a randomly chosen child who completes a Mathlit will be awarded a medal is 1/3. Asha wishes to test his claim. She decides that if she is awarded no medals while completing 10 Mathlits, she will conclude that the true probability is less than 1/3. Use the binomial distribution to find the probability of a type 1 error. So for this one, your H0, your null hypothesis would just be 1/3, P is equals to 1/3, and your H1 will be, the probability is less than 1/3. Okay, so use the binomial distribution to find the probability of type 1 errors. Type 1 is false positive. So we will try and make it that we conclude that probability is less than 10. So we know that the probability of getting awarded a medal is 1/3. So if she gets no medals while completing 10 Mathlits, how would we do this? She's awarded no medals while completing 10 mathlets. So the probability that she does not get a medal is 2/3. And P, so we'll use Px is equals to 0, meaning she gets no medals. And then from this we will have 10 tries, right? So 10C0. And then probability that she does not get a medal is 2/3. Oh, sorry, probability that she gets a medal is 1/3, and we'll use R of that, and 2/3 to the power of 10. So the probability would be 2/3 power of 10, which gives us probability of the type 1 error would be 0.0173. Okay, moving on. B. The true probability of being awarded a medal is denoted by P. Given that the probability of the type 2 error is 0.8926, find the value of P. Okay, so for this one, we would do that she gets. Okay, let's say that if. Oh, wait. Type 2 error, so she does get a medal. So that one will just be 1 minus the probability of her not getting a medal, which would be a false negative, which is a type 2 error. So for this one, it will be 1 minus 10C0 and P to the power of 0, and 1 minus P to the power of 10 will give you 0.8926. So that's 0.8926 minus 1 would be 10C0, sorry, that's just 1 times 1 times 1 minus P to the power of 10, which gives us negative 0.1074. And then if we move the negative over, we'll have a positive 0.1074. And then 1 minus P is equals to 10 root of 0.1074. 10 root of 0.1074. And we get 1 minus P is equals to 0.8000. So therefore our P will be equals to 0.8000 minus 1. And the probability will be 0.19. It'll be negative 0.199. But it'll just 99, it's 999, so we'll just make it 2. 0.200. And then we'll move the negative, it's negative 0.200, but we'll move the negative of the P over and we'll get positive 0.200. Okay, 7A. The diagram shows the graph probability of the probability density function f of a random variable x, which takes the value 0 and 4 only. Between these two values, the graph is a straight line. Show that fx is equals to kx for 0x4, where k is a constant to be determined. Okay, so for this one, we'll just do half times base times height is equals to 1. So So our base is 4. So we will get our height to be equals to 2 over 4, which is half. Our height is half. So from there, we can find the gradient. So gradient is equals to y1 minus y2, which is half minus 0 over x1, 4 minus 0, which gives us half divided by 4, 1 over 8. And when we use y equals to mx plus c, our m is 1 over 8, y is equals to 1 over 8, x, and our c will be 0 because it cuts the y-axis at 0. So therefore, fx is equals to 1 over 8 x. There we go. Okay, moving on. Hence or otherwise, find ex. So we use integration of the curve 1 over 8x, and we will multiply this by x again, so we will have x squared, and we will put the values of the limits. So 4, 0, 1, 8 x squared. That will give us ex. So from this, let's integrate it first. 8 times 3, 24. 1 over 24 x cubed. Then limits of 4 and 0 is equals to ex. So we substitute the values in, we will get 1 over 24, 4 cubed is equals to ex, which is equals to 1 over answer times 4 cubed, 8 over 3. That's your answer. And that's it. Oh wait, no, that's not it. Oh my gosh, one B left. Okay, so for B, given that the median of W is 1, find the value of A. So since the median is 1, we know that everything below 1 would be 0.5, but we know that everything above 1 will also be 0.5. So are we given the value in the function equation? No, we aren't. Oh damn. Okay, so from this we could actually just find that since the median of W is 1 to A, but we wouldn't have the damn. Oh wait, I can think of something. Times base, which is A, and height, you will get half the value of the. Oh yeah, okay. So half times. Wait, no, the median of. Oh yeah, W is 1. So between 1, you would have 0.5, 0.5. But we don't need the y value. Okay, let's find the height first in terms of A. So half times base, which is A, times height is equals to 1. So height should be equals to 2 over A. So we have our height already, it's 2 over A. And from here, we can just do the equation. Oh, sorry, find the equation of the line first. So we'll have y is equals to 2 over A x plus c. Don't know what our c is. Don't know what our c is, so we can't find the equation of the curve. No, sorry, yeah, the equation of the line. No, this is on the it's like on the tip of my tongue, but I can't really get how to do this. But I know I'm very close to it. we need to find the equation of the line. But how do we find the equation of the line? I'm actually not sure. 0.5 is here, 0.5 is here, 1 will be in the middle. So how do we find 0?
Yeah.
How would we find the value? Okay, so I guess since we found the value of h, which is 2 over a, so half a times 2 over a is equals to 1. Oh no, we can't just do that. We can't. Oh, that seems like such a easy way to find what a is, but then a will just, yeah, it will just cancel out. It will just be a equals to 1, which would not be correct. How would I do this? Given that the median of W is 1, I know what I'm supposed to do, but I don't know how I'm supposed to do it. Okay, let's just try algebra, okay? So we will have the integration of 2 over ax plus c, and we will have 1 and 0 as the maximum and minimum limits will be equals to the integration of a and 1, 2 over ax plus c. So c will be equals for will be the same for both. So probably from here we can find it. Okay, so from this, we integrate this first. So we will get bracket 2 over ax, we will have 1 over ax squared plus cx is equals to, so 1 and 0, 1 over ax squared plus cx a1. Oh, then our c will have different values in it. Okay, let's just try it. 1 over ax squared plus c, because 1 will just give you, putting 1 into the x will just give you the normal values, and putting our I'm putting 0 in will just give you 0, is equals to half a squared plus ca minus half, just 1 over a, it's not half, 1 over a plus, no x squared here, c, 1 over a plus c. So from here we would make into a formula, 1 over a plus c plus 1 over a plus c gives you 1 over a squared, you cancel it out, so you just get a. Half a times a squared will just give you a plus ca. A plus ca is equals to, so you'll get 2 over a plus 2c is equals to a plus ca. Oh, you have two different, oh my gosh. Okay, maybe we don't move that half a plus c over. You will just get half a plus c is equals to half, just a minus half a plus ca plus c. Ca minus c. And from here we can just do 1 over a is equals to, oh no, we can't do that. Remove the c. Well, moving the c over will help us actually remove the c. We will just have ca hanging around. Oh, I'm gonna have to look at the mark scheme for this, I'm sorry. I actually don't know how to do this. But I know I'm like very close. Minus 2 over a is equals to 1 over 2. What? Huh? A minus 1. Okay, that gives you the area of the one side. Over a is equals to 1 over root 2. What? trying to make sense of this. I can't. A minus 1 over A is equals to 1 over 2. And how? So answer would just be 3.4. Just give me a calendar. How? 3.41. Wait. This is really confusing. So I did get this 2 over 8, but how did they get there? C. So let's say when we find y equals to 0, x will be equals to a. And then for the equation, the straight line, c would be equals to here, which is how? Okay, I can't figure that out. I'm gonna have to watch a YouTube video on that. How? I really don't get it. How did they do it? Let's just move on from there. We have 8 over 3. Now the next one we have fx is equals to 1 over 8x. Alright. 0.2, okay, 0.0173, alright. Unlikely a candidate who does one theory is likely to do one practical. Alright, so that's correct. 0.977. Okay, I did not get that. 90 minus 125. Oh, he squared it. Oh, it's 1.5 times of that. Okay, that's my mistake. No, I'm supposed to square it. I was thinking of whether I'm supposed to square it or not. Turns out, yeah, you have to square it. Okay, 5a. What is your what's my answer? 0.328. Alright. Oh, probability that difference is more than 2 is equals to. Oh my gosh. Oh no. So we have 1 and 5. Oh, you have to find both sides. It's negative 2 and 2. This one 0.945. And for B, sorry, for C you have 0.0131. 0.0429, okay, for A was received independently or singly or randomly. Oh my gosh. There's evidence that mean mass and contributes different. Alright, there's evidence, but what's the negative 2.655? Alright. Because you can do all. 0.766, alright. 0.167, okay. EW is equals to minus W, okay. Hence 1 minus P must be close to 1. Yeah, alright. Wouldn't be equal, so yeah. 0.176, 0.204. Okay, we're just gonna look at a short video on how to do that one question. Okay. Go to YouTube. 9709 slash. Where's my slash? I got my keyboard's not lit down. Slash 62/m/j/p3. Alright, let's look at this. Let's go all the way to the end. What? That's so much just for.
Which is y minus y1, not y, okay, I will write w. Then w minus a. So from here I will get
the gradient is b over a. Alright.
My equation of the line becomes negative b over a brackets w minus my b.
So you have two different unknowns as well. So the area will be half AB. Alright. Makes sense.
Divided by c over d.
And then you use that to find what B is in terms of A. Equation of the line is equals to GW minus GW. equals to m velocities, sorry, mw minus w1 let's, oh my gosh, what is this? Is this the equation of the line? Let's find a simpler one.
Now my equals to half. Right? Then -1/a squared, two expansion of the quadratic, then it will be a plus b squared equals to a squared plus 4ab plus b squared.
Shit, oh my god. Hey, we have to understand this. GW, the equation of the line, is equals to m bracket w minus w1. When? I've never seen this before.
GW1, yeah. 1W, okay? Then
G1W.
it is going to be W minus W1. Replace my x by W now. Okay, so from here I will get GW minus, I choose the point A. Okay, that means 0 equals to the m is negative b over a. W minus a. So from here I will get my equation of the line become
Okay, so it's equation minus equation equals to negative the gradient. So you just have the 2 points. So it's just y1, y2. But oh yeah, we're trying to find the y value for w. Yeah. Try to find the y value for w.
negative b over a brackets w minus a. This is my GW. Okay, and we know that total area is 21 because again probability density function. So it means that total area 1. Okay, so from here I know that half times a times b is 1 because this is a triangle. And with my equation of the line becomes 0 equals to the m is negative b over a, then w minus a. So from here I will get my equation of the line becomes negative b over a brackets w.
Wait, no. GW minus G1W is equals to mx minus x1. So we use W for, oh yeah, we have it. We're using this value and this value. So,
This is my GW.
so that's the y, that's the equation of the line.
So it means that, or I would say, yeah, with this method, it will be
Okay, so I think I can try and continue from that. Let's try again. So we'll start from that one. We have wy. So y minus y1 is equals to m x minus x1. So another value would be 0, 0x, and by. Sorry, 0y? Wait, what? Ah. 0y would be here. So yeah, we have a here. Okay. So, sorry. A and 0. So So now we will have y minus 0 is equals to, from what we found from the gradient, m is equals to y1 minus y2 over x1 minus x2. We use y1 would be the 0 minus y2, which is b over x1 a minus x2, so we have negative b over a. So we have negative b over a, x would be w minus x1 a. So y is equals to negative b over a, w minus a. Just cross out the previous one first. And then from this, we would use this equation of the line to find our half AB is equals to 1, B is equals to 2 over A. Okay, so we found our B. It's 2 over A. So for this one, given that our value of W is 1, we should be getting a 0.5 as our function. Sorry, I don't think we can move on with this first. Sorry, let me just look at this. How would we progress? Yeah, so since W is equals to 1, we'll just put it as 1. So GW is equals to negative 2 over A squared W minus A. Okay, where's the over A? So we have 2 over, oh yeah, it's B over A. Okay, 2 over A squared. Now from this, since median is 1, our integration of 1, 0, negative 2 over A squared, 1 minus A is equals to 0.5. And then from this, we integrate, taking A squared as the unknown. Sorry, it's A squared as the unknown. Is it A squared as the unknown?
Not 1. Constant. Using, but you
W squared is the unknown. Oh my gosh. So we will have negative 2 over A squared. Sorry, negative 2, W squared over 2 minus AW 10 equals 0.5. Then from this we will have
is this to integrate, but I have another easier method. So I can say that this is ax plus b and dx. Then I will just put the w minus a as 1 term. So it will be ax plus b to the power of n plus 1 over n plus 1 plus c. So I have decided this instead of 1 by 1, because later we need to find what is the A, right? So because now you need to find what is the GW. So now our unknown is the A. So that's why I will use A W minus A squared, because initially it is only 1. Then over to the differential W.
W minus A squared over 2.
Minus, I will continue, next page.
So from this you will get normally, so you would get 1 minus 2a is equals to of the a square over you get 1 over 2a square negative 1 over 2a square. So, gosh.
This 2 up, this a squared. Move to the other side.
So we have 2
So I will get
minus
negative
4a
2
is
brackets
equals
1
to
minus
negative
2a
a square, so we
equals
put
to
a
a
square
squared.
over a square
And then I will do expansion. This is 2 minus 2 times 1 is minus 2.
minus
Minus 2
4a
times
plus
minus 2a will be plus 4a equals a squared. And now you rearrange a squared minus 4a plus 2 equals 0.
2. Okay.
Okay, so now when you use the quadratic formula,
Yeah, we have to use
let's say
quadratic
ax
formula,
squared
and from
plus
that we
bx.
will get our answer. Oh, this is so much for this 3 marks. Damn. So first we find the equation of the line, like they did, and then we put the equation of the line in, and then integrate it equals to 0.5. Yeah. Oh my gosh. I'm gonna have to take a break on this one. But of course we can't. So I'm gonna move on to the next paper. It's gonna take. That is one hard question. I mean, it's not hard, it's just you have to do so much steps for that. Okay, for this one, I'm gonna take a break first. This is a very quick one, like 5 minutes. No, Milo. Milo, no. Milo. Whoa. Yes, Milo? Yes, Milo. Sushi? 真的假的？ Okay, I'm back. Now let's start the paper once again while I charge my phone. Ow. Meow. Meow. My Milo. Hello. Milo. Milo. Moving on. 9709 63 May June 23. So for the first question, find EX. So EX is just X times what? The equation. So we have, so we can take the 3 over 2 out actually. 3 over 2. Integration sign 1 over 0. Sorry, 1 to 0. X times 1 minus x squared. The x we will get 3 over 2 integration of x minus x cubed with limits 1 and 0. And then from this we will get 3 over 2 bracket x squared over 2 minus x 4 over 4 limits 1 0. We will put the limits in and we will get 3 over 2 1 over 2 minus 1 over 4, and from this we will get 3 over 2 1 over 2 minus 1 over 4 3 over 8. Okay, moving on to 8. So 2a. A club has 264 members, numbered from 1 to 264. Donash wants to choose a random sample of members for a survey. In order to choose the members for the sample, he uses his calculator to generate random digits. His first 20 random digits are as follows. The number of the first 2 members in the sample are 106 and 121. Write down the numbers for the next 2 members in the sample. I hope this comes out in the exam because there's no way you can get this wrong. We have 106, 121, and your next number will be 180. So since you see you have 106, 121, and then you have 108. The first numbers of the first 2 members. Okay, so what I'm a bit troubled with is there's 1 to 264 members. So okay, so there's no 0 of course. But okay, given that the first one, okay, sorry, I'm overthinking. Okay, so you have 180, 1 to 1, so you don't write 1 to 1 again since it's a duplicate. The next one will be 473. But since 473 is over the limit, you don't write that. The next one will be 227. It's in the limit, so 2 to 7. For B, to obtain the numbers for members after the 4th member, Donash starts with the second random digit 0 and obtains the numbers 061 and 211. Explain why this method will not produce a random sample. So the reason why it won't produce a random sample is so you have 0.61, 061, 211, and then you will have 801, 214, 732, 275, and suddenly you have a 9 here. Also, okay, so I think the explanation is as chose to start at 0. Hence, no longer random. It's a pretty bad explanation. I'm not really good at giving these answers. We have to find out. Okay, G. Find the two possible values of x. A random sample of 100 students at Louisiana's college. X students said they liked exams. Louisiana used this result to find approximate 90% confidence interval for the proportion P. Width of 0.15792. Okay. So from this, we just need to find n actually. So P, 90% confidence interval. So both sides would be 0.05, 0.05. So from that, we see what 95% is. So that means that one whole side is 95%. So from that, we'll find what 95% gives us, 1.645. So Z is 1.645, so 1.645 root of, so you have to times this by 2, root of random sample of 100 students, X students set the like exams. So you have X over 100 times the 1 minus X over 100 PQ over what? Meow. Over 100, so root of everything, 100 is equals to 0.15792. Dividing it by 2, 0.15792 divided by 2, you would get, sorry, we'll just straight away divide this by 1.645 as well. You get 0.048. So root of x over 100, times 1 minus x over 100 over 100 is equals to 0.048, and we would square this value. Answer square would give you 2.04 times 10 power negative 3, and then you would times it by 100, which will give you 0.2304. So that would mean that x over 100 times 1 minus x over 100 is equals to 0.2304, and you just expand it. X over 100 minus x squared over 1000 is equals to 0.2304. Sorry, 100 times 100 is 10,000. And then from this, you would times the x over 100 by 100 on numerator and denominator as well, so to make it the denominator constant, which is 100,000. So you would have 100x minus x squared, and then you have 10,000 below, so you'll move the 10,000 to the other side. 0.2304 times 10,000, you'll get 2304. So, and then from this we will get x squared minus 100x plus 2304 is equals to 0. And you would do the quadratic formula, negative b, which would be negative 100. So it's just 100 plus minus square root of b squared. So we have 100 squared minus. Wait, sorry. Let's try and see if there's a shorter way to do it. Divide by 12, 192. That will give you the answer. 23004 divided by 20. That's I give you the answer. Not 23004 divided by 40, 576. Wait, sorry. Let me count out. Sorry, I have to go and eat dinner first. I'll come back and complete this. Okay, find two possible values of value x, so continuing off where we left. 2304 divided by 24, you get 96, so does that give you 100? No, it doesn't. So let's try 2304 divided by 34. Nope. 2304 divided by 44. No. 2304 divided by 54. Nope. 2304 divided by 64. 36. 64, 36. Perfect. That gives us 100. Okay. Okay. So now we save time. We don't have to do the quadratic formula. We have x, 36 and 64, and if we minus them together, we will get negative x squared, negative 100x, and positive 2304. So therefore, our x is equals to 64 or 36. Okay, moving on. B. Find the probability that neither of the two confidence intervals contain the true value of p. Suzma independently took another random sample and found another approximate 90% confidence interval for p. Find the probability that neither of the two confidence intervals. So none of them contain the true value of p. So it'll just be, how do we do this again? So I know it's something to do with 90%, the 90%. So we know that the acceptance region is 10%, which is 0.1. So neither of the two confidence intervals. So for it to not contain the true value of p, it has to be it's 0.9 times 0.9. So it's 0.81. 4. Find the probability that the total profit made in a randomly chosen 7-day week is less than 22,000. So per day is 65.2. So 7-day week, 7 times 65.2 gives you 456.4. Okay, and that we have the mean already. That's the mean for the tons produced, and then from that we can find the. And then we times this by 50 because we want to find the profit. 22,820. Okay, and then the standard deviation is 3.6 tons. So the standard deviation will be equals to 7 times 3.6 times 50, which should be equals to 1,260. Okay, now we have the mean and the standard deviation. Now we can find probability. Probability that x is less than 22,000. So 22,000 minus 22,820 over 1260. Px less than. So we will have 22,000 minus 22,820. Divided by 1260, negative 0.651. So negative 0.651 is less than negative 0.651. So 0.65742274425. So it's 1 minus 0.7425, which gives us 0.2575, so it's 0.258. Okay, moving on. Number 5. Find the unbiased. Okay, this is easy. The mean is equals to 1,700 over 50, which gives us 1,700 divided by 50, 54. And the variance would be n over n minus 1, ex squared over n minus ex over n squared, which is equals to 50 over 49 times 59,050 over n, which is 50, minus 34 squared, which gives us 50 over 49 times 59,050 over 50 minus 34 squared, giving us 25.5. Oh, lastly, the mean time for pizza deliveries at Pete's Pizza Pit was 32.4. This year, the time T is quoted. Oh, okay. No. Next one, B. Test at a two significance level whether the mean delivery time has changed. Okay, it just has changed, so we're gonna use more than. So we're gonna find more than. So let's see if it's more than. We'll have 34 minus 32.4 divided by the variance, which is 25.5, and we will divide this by the n as well. So from this we will get 2.24. Px is more than 2.240. So it's actually 34 minus 32.4 divided by root of 25.5 over 50. And then we will get 2.24. So more than 2.24, we will get 1 minus the phi of 2.24, which gives us 1 minus 2.24, 0.9875. So 1 minus 0.9875, that gives us 0.0125, which is less than 2%, less than 0.02. Therefore, reject H naught as evidence enough to suggest delivery type has changed. Okay, 6, moving on. Oh, sorry, we have C. Under what circumstance will it be unnecessary? Will it not be necessary to use the central limit theorem in answering B? What's the parameters again for us to know whether we use central limit theorem or not? I'm guessing it's like n is more than, n has to be more than or equals to 50. So under what circumstance? Okay, so we would say n is less than 50. Okay, moving on. 6a. It's known that 1 in 5,000 people in Atalia, sorry, I read that as Africa, have a certain condition. A random sample of 2,500 people from Atalia is chosen for a medical trial. The number having the condition is denoted by X. So the probability is 1 in 5,000. So then our mean will be equals to 1 over 5,000 times 12,500, which gives us 0.02. 5 over 2. So since our NP is less than 5, we would use the Poisson. So approximating distribution to find the P is less than x is less than 3. Alright. So Poisson E negative 5 over 2. So 0 will give us 1. 1 will give us 5 over 2. 2 will give us 5 over 2 square over 2 factorial plus 5 over 2 cube over 3 factorial. Okay, so E negative 5 over 2, 1 plus 5 over 2 plus 5 over 2 squared over 2 factorial plus 5 over 2 cubed over 3 factorial. That gives us 0.758. There we go. 0.758. And then next one, we find the values Ex and variance x and explain how our answer suggests that the approximating distribution used in A is likely to be appropriate. So the values of Ex and variance x would be equals to 5 over 2. Because for Poisson, if we move it to normal distribution, as long as we use Poisson approximation distribution, if you were to convert it to normal distribution, your mean of the Poisson would be equals to the same as the Ex, the mean, and the variance of the normal distribution. So that's why it's equals to 5 over 2. And how it's likely to be appropriate is because NP is less than 5. Okay, moving on. 7. Verify that f can be a probability density function. So for this one, we know that the radius is root 2 over pi. So the radius is pi r squared. So pi root 2 over pi squared should be equals to 1. Sorry, half pi r squared. Because it's a semicircle. So let's put this in the calculator. Half pi root 2 over pi square equals to 1. And we can therefore conclude. And then we also need to show that fx is more than or equals to 0. Okay, moving on. I think we just give an extra explanation area under the graph equals 1. Therefore, it is a probability density function. So A and B. This is the last. Oh, we have an 8. Oh no! Oh, I thought that was the last question. All right, so I guess this paper was kind of easy. So that's why we have 8 questions. 7B. Show that the angle AOB is 1 over 4 pi radians, and hence find Px is more than root 1 over pi. So AOB, we just need to find that this is 1 over 4 pi. So we know that this is root 1 over pi. Okay. So that means that this is also this is root 2 over pi. Because the radius is still this. So therefore, we would use the adjacent and the hypotenuse, and we would have cos pi is equals to adjacent over hypotenuse, so you would have root 1 over pi over root 2 over pi. So theta will be equals to, which let's just put A over B, is equals to cos negative 1 root 1 over pi over root 2 over pi, and that will give you shift cos root 1 over pi root 2 over So, sorry, I forgot to convert it to radians. So that's 1 over 4 pi. And we have to put show. And then hence, we need to find that px less than, no, more than 1 over root 1 over pi, which is over here. We have to find that. So we have the arc. This is just a arc. So we know that this is, sorry, let's write down px more than root 1 over pi. And we know that the AOB is 1 over 4 pi. So area of sector is equals to half r squared. So it's 2 over pi squared theta, which is 1 over 4 pi. From that we get half times root 2 over pi squared times 1 over 4 pi. That gives us 1 over 4. And then from that, we just minus it with the triangle. So we have, sorry, I think we have to find BA first. So for the triangle, since we know that this is 1 over 4 pi, and we know that one side is 1 over root 1 over pi, the opposite, so we need to find the opposite and adjacent, which is tangent, negative 1. Sorry, just put tangent 1 over 4 pi is equals to 2, so opposite, and then you move the adjacent over, so root 1 over pi times tan 1 over 4 pi, so you get root 1 over 4 pi times, sorry, not 1 over 4 pi, root 1 over pi times tangent 1 over 4 pi. That will give you 0.564. So from 0.564, we will find the area of the triangle. Area of triangle is equals to half times 0.564 times height. Sorry, that's already our height, times root 1 over pi. And that gives us half times answer times root 1 over pi, 0.159. So therefore our answer is 1 over 4 minus 0.159, which gives us 0.091. 0.091. There we go. Okay, moving on to A. Sorry, 8A. A new light was installed on a certain footpath. The town council decided to use a hypothesis test to investigate whether the number before the light was installed, the mean number of people using the path during any 20-minute period during the evening was 1.01. After the light was installed, the number n of people using the path during 3 randomly chosen 20-minute periods during the evening was noted. Given that the value of n was 6, use a Poisson to carry out the test at the 5% significance level. Okay, 3 randomly chosen 20-minute periods. Whether the mean has increased. So we would have to do 1.01 times 20. No, sorry, times 3. So we get 3.03. So our hypothesis for whether it's increased will be more than 3.03. So given that the value of n was 6, Given that the value of n was 6, will the Poisson to carry out the test and 5% significance of this? What would we use for this? So we definitely can't use the Poisson distribution because n is less than 50. So the only thing we can use is so given that n was 6, so that means that 6 people used the footpath during 3 randomly chosen 20-minute periods. So that just means that p of x is more than 6 minus 3.03 divided by the root of 3.03 is equals to 6 minus 3.03 divided by root of 3.03. That gives us p of x is more than 1.706. Okay. And then from here we find 1.706, 1.706, 0.9608. So from this we already know that it's, oh no, sorry, we already know that this is going to be reject the h naught, but we have to do it, of course. 0.961 again, 79608. Oh, sorry, that's 1.70, 0.9554, 6, 0.9559, 0.9559, which is equals to 1 minus 0.959, 0.0441, and this is less than 0.05. Therefore, reject h naught as sufficient evidence, same thing, to support that amount of people using footpath has increased. Okay, moving on to B. Later, similar tests at the 5% significance levels carried out using another 3 randomly chosen 20-minute periods during the evening. Find the probability of a type 1 error. So for B, we know that type 1 is equals to false positive. So in order to find the probability of a type 1 error, we actually just have to show that it is less than 0.05. So let's try and make it 7 people using the pathway n is equals to 7. So let's try n equals to 7. Oh, sorry, this is not Poisson, we can't use it. So what we've already found just now is that the problem 0.0441 is already positive. So that could be a type 1 error. So therefore, type 1 error is equals to 0.0441. State what is meant by type 1 error. Conclude more, but reality no change, or just not more. For the state and context, what further information will be needed in order to find the probability of a type 2 error? So what do we need to do a type 2 error? So type 2 error is that it is, sorry, the number has not increased. We find out that it's not increased. So what further information do we need to find that it has not increased? Exact value of people using FitGraph, I guess. Okay, let's mark. MS6 true. A value for the true mean. True mean. Alright, a number of people using the path per 20 minutes in the evening. It is 20 minutes, right? Yeah. Okay, so I did get 1 mark for that. But a value for true mean. Yeah, since we can't use Poisson, so we need the exact mean for this. X1, we will have C will be concluding that. Okay, got that already. And then for 8B, oh, they used Poisson. Are we supposed to use Poisson? Oh my gosh. Oh. All the way to 5 since n is 6. Oh yeah. Since n is 6, we will have to use, okay, since the test value is 6, we use more than, oh yeah, has to be more than 6, more than or equals to 6, so we would use 1 minus e. Oh my gosh. Use points. For this, we will go all the way to 6. We just find the value that gives us a false positive. Continue on until it gives us a positive, that means less than 0.05. And that would be your probability. Oh my gosh, how did I mess up this badly? To look up the parameters for whether you should use Poisson or normal and all that stuff. I need to revise all that. 7b, 1/4 minus 1/, what? 1/2 pi? What did I do wrong? There's a curve? Oh yeah, there's a curve. Why do we find the curve? Why can't we just use the area of the sector? The area of the sector minus the triangle would give us the answer here. Oh, there's both sides. Wait, no, but that doesn't make a difference as well. 2 times 0.15. Well, A is correct. For B, area of sector is 1/4. Alright. Area of triangle AOB is. Oh, okay. Area of triangle AOB is 0. Oh, yeah, wait, I did get it. Yeah, 0.091. Yeah. I knew I didn't do anything wrong. It's 1/2 pi or that. Okay. Okay. I was confused here. Why? Okay, 6b. They're almost equal. Oh shit. Yeah. They are almost equal. Six A 0.758. Okay. 5C, distribution of times in the population is normal. Yeah, I'm really not good at describing and explaining all this stuff. Distribution of times in population is normal. 5A, 25.5, okay. Do not reject. I did get it correct. Okay. So when you're trying to find out whether it has just changed or not, you don't have to use a value. You don't have to use more than or whatever. You just find this and you will get 2.24, and you will compare it with whatever the parameter is given, and if it's less than what is given, then yeah, okay. So just leave it off at. So just leave it off at 2.24. Okay. 4 0. What? 258 is not. That's the standard deviation. Oh my gosh. There's too much careless mistakes. 4, 5, what? Oh, is the standard deviation so large? Variance 50 squared. 50 times. Oh. Should be 0. Oh, I did it wrong. 0.1 squared. And 64, 36. Alright. 180, 227. Only a finite. These numbers are not independent of the previous number. Oh yeah. Not independent of previous number. And 3 over 8. So overall, this paper I did horrible. I think it was only like 80%, which is an A, but it's horrible. Okay, so I'm gonna have to revise this a lot. So I might not stream tomorrow, but I'm gonna study the whole day of tomorrow. I mean, that's pretty unrealistic, but almost the whole day of tomorrow, because me and my friend have to go to somewhere to just study and study and study. Yeah, so hopefully I'll do really well on Monday. So good luck to everyone taking P6 on Monday. And yeah, I'll see you on Tuesday, maybe Monday afternoon, when I revise for what's next. Where's my timetable? Wednesday. Oh no, it's not Wednesday. Monday, Tuesday, Wednesday. Oh, Wednesday, mathematics, paper 3 maths. And that'll be all for my maths papers. So yeah. I'll see you guys next time on Tuesday.